One of the more interesting and enduring tropes in science fiction is the idea of anti-gravity, being able to hover or react opposite to the force of gravity. This idea oddly goes back a very long time, to as early as 1638 with Francis Godwin, and a posthumously published novel of men going to the moon. Moon being spelled with an E. This was so early. Levitating against the force of gravity by turning it against itself, perhaps even allowing Superman-like powers that allow one to fly freely and never fall to the ground, is alluring. And there would certainly be many practical uses for such an ability and technology, at least on its face. But in most depictions of anti-gravity, it actually isn't really the same as it is in physics. It's the partial mitigation of gravity in sci-fi, but not totally canceling it out. You can see this with Star Wars, where Luke Skywalker's land speeder hovers, but still stays in some way gravitationally bound to Tatooine, or else the speeder would have flown off into space if it was truly anti-gravity. But the reality of that is far more complicated and doesn't actually amount to true overarching repulsive gravity, more on that in a bit, but it does lead to some bizarre effects. There is a certain artistic license in sci-fi that usually always imposes some kind of rules on the physical reality of true anti-gravity, but the reality is that it probably cannot exist, but a conditional partial form of it might. As a weird science-related trivia aside that is not well known in the Star Wars community, George Lucas had been scouting Tunisia for filming locations for Tatooine, and ran across a town called, aptly, Tatooine, and named the planet after it. It was just spelled differently. But there was a strange astronomical connection there in that specific town. The actual real town of Tatooine saw a meteorite fall on June 27, 1931. The meteorite is a very rare type called a diogenite that is believed to have originated on the asteroid Vesta. The meteorite is actually a really weird olive green color, which might scare Superman actually. Green crystals are not his thing, because it's made of orthopyrazine crystals and remains one of the more odd meteorites geologically that's ever been found. I'm not sure Lucas knew about that at the time, but it did happen. But I digress. The actual idea of anti-gravity is problematic. We know that particles have charges, positive and negative. But gravity is different. It doesn't seem to have this. The reality is that there aren't a lot of ways within known physics to produce an anti-gravity effect. Basically, there are two, and maybe a third, but it is more speculative. These options were floated mainly because we do not have a decent theory of the nature of gravity. We don't know what it is. We just know how it behaves on large scales through relativity's description of it. But we do not really know how it behaves in the subatomic world because there, gravity is so weak that it's almost impossible to measure. General relativity, however, does allow for anti-gravity in a specific way, known as the equivalence principle, which defines gravity as a curvature of space-time. But hidden in that is the possibility that negative mass can satisfy the principle. In short, it means that anti-gravity is not ruled out by known physics. We have just never seen anything do it. But it has been looked for. So one possibility that was floated in the past is that one potential path to anti-gravity is matter and antimatter. The idea was that antimatter might actually have been anti-gravity in nature, and that idea persisted until relatively recently, because it was extremely difficult to measure and test. But it finally happened, and it turns out that it does not seem to be the case, at least with antihydrogen. It does not exhibit a repulsive effect in a gravitational environment. In other words, antimatter falls just like normal matter. It's important to note that anti-gravity does not actually mean anti-weight per se. You can be in a free fall like in the famous NASA Vomit Comet aircraft simulating zero gravity and approximate the cancellation of gravity. And you can electromagnetically levitate things and the like. Instead, it means truly counteracting the force of gravity with an anti-force, not merely canceling out, but repelling against it through other means. The other option put forward in the past is not settled. It is the creation of negative mass or energy, and that would actually also not be true anti-gravity in that sense. The problem is that while physics does not prohibit negative mass or energy in this sense, there is also no evidence it exists in nature, and there is no known way to create it. It's just a mathematical flipping from a plus to a minus ultimately in an equation. It would certainly be nice if we could find negative mass matter though. That would allow for traversing stable wormholes and black holes, if that's actually possible, the Alcubierre warp drive, and because of the nature of ideas like that, backwards time travel. But ultimately the whole idea is sort of contrived mathematics under general relativity. It probably doesn't actually exist. Nature probably never created the conditions for it, and we probably couldn't either as a result. But there is room to speculate there. Under both general relativity and quantum mechanics, gravity derives from the presence of mass and energy and is thought to always be positive, never negative. Meaning true anti-gravity isn't even merely impossible, but it's a misnomer, and it may not even make sense to term it as anti-gravity, any more than saying a banana has a counterpart, non-banana, that is nevertheless still a banana. You can have an anti-banana though. You can make a banana in principle out of antimatter, but don't do it. It will mutually annihilate with matter, and certainly do not attempt to eat one if you ever see one. That would leave a crater. Whether you can have a negative mass banana remains to be seen, but the idea of gravity being a solely repulsive force has a long history. It actually goes back to James Clerk Maxwell in the 19th century. He was a major figure in the study of electromagnetism and noticed, long before Einstein and general relativity, that gravity seemed different from electromagnetism and did not seem to have a possible repulsive counterpart. This only got worse with general relativity and quantum theory as those ideas were developed. This was due to the nature of what was being described. Charges are one thing, but mass energy is another, and somehow, and this is not fully understood, it in some ways stops making sense to apply a negative to gravity itself. It just doesn't seem to work that way in the nuts and bolts of what we do know, despite our lack of knowledge of what gravity actually is and the nature of it. There have been many claims over the years of anti-gravity in experiments, such as those done 100 years ago by Thomas Townsend Brown. But every time, either the experiment was unrepeatable or shown to be a misinterpretation of another effect. But the second possibility for anti-gravity has an even more interesting history than matter and antimatter, the idea of negative mass. There is a lot more going on with this one. So negative mass, as I said, is totally hypothetical, but it is a form of exotic matter, one of several, that would exhibit strange stuff above and beyond anti-gravity. Basically, if you apply force to this kind of material, even gravity, you get the opposite reaction from it. Push it and it pushes back. We have actually seen one slight indicator that may be relevant here, in that what we do see that does seem to resemble repulsive gravity is dark energy and the expansion of the universe. Here, if you could figure out a way to harness dark energy, then there might be a path to negative mass. This leads to some weird effects. So if you had an object of negative mass, let's say we have a negative mass party balloon shaped like a banana, and you pull down on it, it would respond by pulling up. This would happen even on the moon with no air, but if you leave it alone, it will not fly off into space. Rather, it will fall to the ground. Pull it, it goes up. Don't pull it, it comes down, to simplify it greatly. So let's imagine a starship. If your starship is of normal, positive mass, and you suspend a body of negative mass in front of it and connect the two with a cable, if you pull on that cable, you move forward. Let the tension on the cable off and instead push on the negative mass instead of pull, the starship stops. This would be unbelievably efficient in that the only fuel, the only expenditure of energy in the system is creating tension and applying it to speed up or slow down. The actual cruising requires effectively nothing. It's almost a free lunch for space travel. Worth noting here is this requires two masses of opposite signs. So if you have two masses of positive mass, you get what we have, regular gravitational attraction. If you have two negative masses, however, they repel each other, which is probably going to be a problem if you can indeed create the material. When you get a positive and negative mass together, you get both a push and a pull at the same time. That leads to this weird hypothetical effect of partial anti-gravity, if it can even be termed that. Building something that moves away from you when you pull on it also presents some manufacturing challenges, but they can be overcome in principle. But even without a string, Herman Bondi realized in 1957 that this still happens anyway. Something with positive mass and something with negative mass still interact gravitationally, if under different rules than what we're used to. But the trick is that you need a lot of positive and negative mass for that interaction. The smaller you get, the more negligible it becomes without a string. But here we run into the strangest effect of this at all. If you had a positive and negative mass interacting in this way, they would accelerate with no upper limit other than the speed of light, and it would cost virtually nothing in energy to get there. This allows for things like perpetual motion machines, near the speed of light travel, and so on. But ultimately, to change this and get into actual true anti-gravity, you would need general relativity to be superseded by a more complete theory that predicts such a thing. But there is one other option. In quantum mechanics, gravity is not understood very well, as I mentioned, because it is incredibly weak and hard to measure. It exists there, but it is really tiny. The question has always been whether it is a particle exchange like the other forces are, or is it something else? If it is a particle, it's called the graviton already. And there things get weird again, because of how particles behave in experiments, like the double slit experiment, where they are both a wave and a particle, depending on what you do. Does the graviton obey that? And what does that mean? No one really knows. Thanks for listening. I'm futurist and science fiction author John Michael Godier, currently glad gravity exists, as it would be rather difficult to write a script for a video if I wasn't glued to my chair by Earth. I don't even want to contemplate what a negative mass drink would do to my computer and ceiling. And be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.